right, today we're doing 3-5. It's real similar to 3-4, but now we're solving equations by multiplying or dividing. And it's going to be similar in that you have something done to x equals some number. You look at, okay, what was done to x? I need to do the inverse. This first thing here I wouldn't write, but yesterday we had the addition property of equality. We said if one number equaled another number, you could add the same amount to both sides and it's still equal. Or you could subtract the same amount from both sides, it's still equal. Good? I'm not going to write out the whole title and everything, but we do the same thing. They have a multiplication property of equality, and they say like if A equals B, or you could say like if 5 equals 5, and I wouldn't write this if I were you, but what the multiplication property of equality is saying, well, if I do times 2 and times 2, kind of like 5 times 2 is 10, 5 times 2 is 10, right? If you multiply both sides by the same amount, it's still equal. And the same is true if you divide, because dividing by 2, say you have like 10 equals 10, divide them both by 2, you get 5 equals 5. Dividing by 2 is the same as multiplying by 0.5. So dividing by 2 is the same as multiplying by 1/2 or by 0.5. So you can add something to both sides still equal. You can subtract something from both sides still equal. You can multiply something to both sides still equal. Divide both sides by something still equal. Good? So as long as you do the same thing to both sides, it's still going to be equal. So that's one thing. What I would write down is I want to get this term like coefficient. Is that something that looks familiar to you guys? I-C-I-E-N. A coefficient is really just a number times a variable, or a number before a variable, you could say. So a number before a variable. So in other words, if we have like 3x, 3 is the x coefficient. And if you had to put a math operation in between there, it's not 3 plus x, it's 3 times x. So if you just have a number and then a variable immediately after that, it's always multiplication. You don't have to do the little multiplication dot. Good? Okay. So we have that. Now really just a couple examples and we are done. This first one, I'm going to say, all right, I have 7x equals 42. So to solve this, we say, well, what was done to x? X was, Luke? Perfect.
And then because divide by 7.
Good. So you're saying divide both sides by 7. And when you do that, you can cross out the 7s, because x times 7, x divided by 7, they're inverses, so they'll cancel. And then you get x equals, 42 divided by 7 is 6. So 3 steps there. First, you copy down the equation from the book or from whatever. Then show what you do to both sides. And then write your variable equals whatever. So I'm looking for those 3 steps again in the homework. Example 2, I'll just write 1/3 x equals 42. Now you have a couple options on how to solve this bugger. What would be one thing you could do to both sides? Go for it, Grayson.
Divided by 1/3.
Yep, because it's this whole 1/3 times x, you could divide the whole thing by 1/3. And if you use your fraction key on your calculator, that's one way to kind of survive it. I like doing that, especially if you have like 2/3 x equals something. But now the left side is just going to cancel, leaving me with x equals. The right side, dividing by 1/3 is the same as multiplying by 3. That's going to end up being 126. Sounds like we should review that a little bit. If you have a fraction divided by a fraction, could I convince you that 42 is the same as 42 over 1?
Yeah.
So you could take and say, well, 42 over 1 divided by 1/3 is the same as times 3 over 1. Remember, you multiply by the reciprocal of the denominator. So that's how I got my 42 times 3, and that answer has to be divided by 1 times 1. So just divide it by 1. Good? So if you had like a 2/3 x, then you would just divide both sides by 2/3, right? So then that's the same as multiplying your number by 3 over 2. For another example, I'm going to say x divided by 4 equals 20. And we do the same steps as before. We say, all right, well, what was done to x? X was divided by 4. So we say, okay, what's the inverse of dividing by 4? And that would be multiplying by 4. So I'm going to do a times 4 over here on the left side and a times 4 there on the right side. Well, dividing by 4 and multiplying by 4 are inverses. So those will cancel each other out, leaving us just x equals. And 20 times 4 is 80. Last example, negative 2x equals 154. What do you do to both sides? Anyone? Just shout it out.
Divide by -2.
Nice. Divide by -2. I put in that negative, wonder if that might trip people up to say, oh, I need to add. But you always look at how it's connected to the variable. Negative 2 is connected by multiplication. So to unconnect it, we're going to do that division. Anybody do that one in their head? Negative 77. Negative 77.